Imagine a planet drifting through space with no sun, no warmth, and no daylight, completely alone, moving silently through the darkness between the stars. These are called rogue planets, worlds that are not gravitationally bound to any star. Without a nearby sun to illuminate them, they exist in a cold, dark state, making them some of the hardest objects in the universe to detect. For a long time, astronomers thought these planets were rare, but recent discoveries suggest the opposite may be true. New research indicates that rogue planets could be far more common than planets orbiting stars. Scientists from NASA and Osaka University in Japan estimate that there may be up to 20 times more rogue planets than stars in the Milky Way. That would mean trillions of Earth-sized worlds drifting freely through our galaxy. Other studies suggest that rogue planets may be 6 times more numerous than starbound planets, far exceeding earlier estimates of around 400 billion. In other words, our galaxy may be filled with invisible worlds we are only now beginning to notice. So how do planets end up completely alone in space? Astronomers believe there are two main pathways. Some rogue planets may form directly when clouds of gas and dust collapse under their own gravity, creating planet-sized objects that never become stars because they lack the mass to ignite hydrogen fusion. Others may begin their lives orbiting stars, only to be violently ejected during the chaotic early stages of planetary system formation. Gravitational interactions between planets, or encounters with binary star systems, can fling these worlds into interstellar space, where they wander forever. This idea of planetary ejection may sound extreme, but it could have happened much closer to home. Studies suggest that when our solar system was less than 600 million years old, the giant planets experienced a period of intense dynamical instability. Simulations by astronomer David Nazorny show that the solar system may have originally contained more than 4 giant planets. In many models, a fifth gas giant is eventually ejected entirely. Surprisingly, starting with 5 giant planets instead of 4 makes simulations of today's solar system almost 10 times more likely to succeed. That violent ejection may have helped stabilize the inner solar system and even protected Earth from catastrophic disruption. As more rogue planets are discovered throughout the galaxy, the idea that our own solar system lost a planet is starting to look increasingly plausible. But if these planets have no stars, how do we even find them? Detecting rogue planets is incredibly difficult because they emit little to no visible light. One method relies on thermal emission. Young rogue planets are still hot from their formation and glow faintly in infrared light. Using this technique, astronomer N. Miret-Reig and her team identified at least 70 rogue planets in a nearby star-forming region, with estimates suggesting the true number could be as high as 170. Another powerful method is gravitational microlensing, currently the only way to detect low-mass free-floating planets. When a rogue planet passes almost perfectly in front of a distant background star, its gravity bends space-time and briefly magnifies the star's light. These events are rare and short-lived, sometimes lasting only a few hours, but they reveal planets that would otherwise remain completely invisible. This search is about to accelerate dramatically. NASA's Nancy Grace Roman Space Telescope, scheduled to launch by May 2027, is expected to revolutionize microlensing surveys. By monitoring the densely packed center of our galaxy, Roman is predicted to detect thousands of planets, including ice giants and rogue worlds. Recent studies suggest it could discover around 400 Earth-mass rogue planets, far exceeding earlier estimates. Early results also indicate that Earth-sized rogue planets may be more common than larger ones. To improve accuracy, Roman's observations will be combined with ground-based telescopes, such as the Prime Telescope in South Africa. And then comes the most surprising discovery of all. Rogue planets may not be as lonely as we once thought. A groundbreaking study led by astronomer Belinda Damian at the University of St. Andrews suggests that some rogue planets can host their own miniature planetary systems. Using the James Webb Space Telescope, astronomers observed 8 young free-floating objects with masses between 5 and 10 times that of Jupiter. 6 of them showed clear signs of warm, dusty disks, the same kind of environments where planets form around stars. Even more remarkably, Webb detected silicate, dust, water, and carbon dioxide within these disks, key ingredients for forming rocky worlds. This was the first time silicate emission had ever been observed around a rogue planet. These systems may be tiny versions of planetary systems, perhaps 100 times smaller than our own, but they reveal something profound. Planet formation is not exclusive to stars. Even worlds drifting alone through the darkness of interstellar space may be building planets of their own.